day world and welcome to the vlog. If you're new to the channel, you're very much welcome. So today we're going to have the first installment of our new series. It's a mathematics or the math series, and that installment is a real number system. To those who are curious, I've started this series in order to be an additional learning resource to our grade school, middle school, high school, and university students who'd like to master some mathematical concepts. Before we proceed, let's give a massive shout out to our frontliners for their endless efforts against this COVID-19. Thank you very much, frontliners. Also, mega shout out to my family, my friends, my childhood friends in PCG, Kuligligs, Dickies, to my subscribers, and to Team Vitroso, Team PP, and Team Gigil. I hope you're all doing great today. And again, massive shout out to our very own Ate Susan Trinidad. Thank you very much for your Sansival and your Tinamok. If you'd like to order from Ate Susan, please check and like her Facebook page. That's Susan's Kitchen. So guys, let's go. Let's go to real numbers. The system evolved over time by expanding the notion of what the word number means. So introduced in the 17th century by René Descartes, a real number is the value of a continuous quantity that can represent a distance along a line. This is our number line. We've got 0 at the middle, extending to your right are the positive numbers, while extending to the left are the negative numbers. Hence, with the definition of real numbers, we can say that numbers like 1, -1, 1.5, 1/2, and pi are real numbers. So, if there are real numbers, then we've also got the imaginary numbers. An imaginary number is a root of a negative number, which cannot represent a distance along a line. For example, we've got the square root of -1. Our answer is a small letter I, which represents an imaginary number, or which indicates that the answer is an imaginary number. So real numbers can be classified as rational or irrational numbers. A rational number is any number that can be expressed as a ratio of two integers or as a fraction. Let's say that if x is equal to 5 and y is equal to 2, then x divided by y is 2.5. Then we can say that 2.5 is a rational number. So now we've tackled rational numbers, let's move on to the irrational numbers. So as the opposite of the rational numbers, an irrational number cannot be expressed as a ratio of two integers or a fraction. For example, the square root of 2 and pi, which represents the ratio of a circle's circumference to its diameter, are irrational numbers. Then what about pi? If it's a ratio, why is it classified as an irrational number? And while it's a ratio, it's not a ratio of two integers, as what we've got from the definition of rational numbers. Now we've defined rational and irrational numbers, let's talk about some ways on how we can further differentiate the two. Let's have a look at these examples. For rational numbers, we've got 3/7, which is 0.75 in fraction form. It's rational as it's terminating or ending. How about 2/3? It is equivalent to 0.66666 and so on, or 0.6666 with a bar. That over bar above the two sixes indicate that it's non-terminating. But the number is repeating, as evidenced by the several sixes that you can see on the screen. Thus, it's rational. 1/11 is equivalent to 0.09090909 and so on, or 0.090909 with an overbar. It is also non-terminating but repeating, thus it's rational. Lastly, we have 5/7, which is equivalent to 0.71428571428, or 0.7142885 with the bar or overbar. This is also non-terminating but repeating, therefore it's also rational. So for rational numbers, we've got terminating or non-terminating but repeating patterned decimal forms. Now let's go to the irrational numbers. Let's have a look at the square root of 2, which is equal to 1.41421356 and so on. It's non-terminating but it's non-repeating, thus we classify it as irrational. The same goes with pi, which is equal to 3.1415925 and so on. It's also non-terminating and non-repeating. Therefore, pi is also an irrational number. Moving forward, rational numbers can be integers or fractions. An integer is a number that can be written without a fractional or decimal component. That means 7, 0, and -7 are integers, while 7.7, 1/7, and the square root of 7 are not integers or non-integers. Also, integers can be negative, 0, or positive. Going back to our number line, you can see that 0 is at the middle. Then, the negative numbers represent the distance to the left of 0, while the positive numbers represent the distance to the right of 0. While integers can be marked directly on the number line, we can also say that fractions are part of the number line. Fraction is defined as a part of a whole, but mathematically, fraction is a number that can be written as x over y, where x and y are integers and y is unequal to 0. You know that the number above the fraction bar is the numerator, while the number under the fraction bar is the denominator. And the fraction is proper if the numerator is less than the denominator, such as 4/5, and it's improper if the numerator is greater than the denominator, such as 10/3. That means if y or the denominator is 0, then the answer would be undefined. We are now aware that positive numbers are the numbers that extend to the right-hand side of 0 on the number line, and they can be whole numbers as well as counting or natural numbers. Natural or counting numbers are the numbers you first count with, and these start from 1, 2, 3, and so on. Meanwhile, the whole numbers are your natural or counting numbers plus the number 0. So that's it guys, that's our real number system. In a nutshell, you've got the real and imaginary numbers. The latter are the roots of negative numbers, while the former represents a distance along the line. And they can be rational and irrational. Rational numbers can be integers or fractions, including terminating and non-terminating but repeating or pattern decimal equivalents. On the other hand, irrational numbers include pi, some number roots, and non-terminating and non-repeating decimals. Integers can be 0, positive, and negative, while fractions represent a ratio or a part of a whole. Meanwhile, positive numbers can be your natural or counting numbers, which are your 1, 2, 3, and so on, and your whole numbers, which are your 1, 2, 3, and 0. So guys, this ends the first installment of our math series. I hope you've learned something new or you've refreshed your knowledge about the real number system. And let's go to our quote of the day. So it's a Japanese proverb which says fall 7 times and stand up 8. For me, that means no matter how many times you fail, don't give up. For instance, even if you've taken IELTS or ROET or your examination 7 times, give one more shot. If it's your goal, for instance, to study, to work, or to move into another country, don't give up. Also, experience is the best teacher each time we fail, and we use that lesson from our failure or from that experience in order for us to succeed. If you like the content of today's vlog, feel free to click the thumbs up button, hit subscribe, and hit the bell icon for future updates. So that's for now guys, I'll see you later. Goodbye!